All right, our last portion here is we're going to find the minimum and maximum values on a parabola. And so the key here, the key formula here is x equals negative b over 2a. So you see a lot of things on the page here when you're looking in the book, but the key part here is to find the x value of your minimum first. The way we do that is negative b over 2a. Once we have that, once we've figured that out, we can figure out the y value by plugging it in. And that's all this is saying here. F of negative b over 2a says once we've found the x of the minimum, negative b over 2a, plug it in to the y. So let's go ahead and try it. A baseball hit at a point 3 feet above the ground at a velocity of 100 feet per second and at an angle of 45 degrees with respect to the ground has a function given here. F of x is the height and x is the horizontal distance. What is the maximum height reached by the baseball? All right, so we're going to use our formula for finding a maximum. Now the formula for finding a minimum is exactly the same. It's not going to change. You'll use negative b over 2a. On this problem, we just have to understand, based on our leading coefficient being negative, this parabola opens downward, which means the vertex is at the top, which means that in this problem, we have a maximum. If it opened upwards, we'd have a bottom, which means we would have a minimum. All right, so let's go forward and solve. We have negative b. In this case, what's the coefficient of x? Just 1 over 2 times a, which is negative 0.0032. All right, and so we're going to plug that in. And if we divide those two things, we end up with x equals 156.25. All right, that's the x value at the maximum, though. Look at what the question's asking, though. We want the height. Is the height the x or the y value? It's the y value. So we need to go ahead and plug this 156 back into the original equation and find f of 156.25. So everywhere we see x, we're plugging in 156.25. In this case, we square it. In the next case, we just add it. And then finally, we need to add 3 because the starting point was 3 feet off the ground. Plug all those things in, and you should end up with 81.125 feet off the ground. All right. The other option that you could do is plug this into your graphing calculator. You're going to get a parabola, and then remember we do have the max function, and it will spit you out 81.125. So you can do it either way. All right, last example to try for your homework. Give it a shot. All right, let's see how you did. On this one, we're going to say x equals negative 24 over 9 over 2, negative 4 over 9. And so what we have here is negative 24 over 9. I'm going to go ahead and times the reciprocal here. 2 times 4 is 8. That goes on the bottom now. 9 goes on the top. Remember, 2 times 4/9 is going to be negative 8/9, and we're just flipping that over. Go ahead and cancel your 9s. 24 divided by 8 is 3, and the negatives cancel out. So your x value is 3. We want the maximum height of the diver, so we want the y value. So we're going to need to go back in and solve if x is 3. So negative 4 over 9, 3 squared, plus 24 over 9 times 3 plus 12, and they made the numbers nice and easy for us. 3 squared is 9. That cancels out. We have negative 4. 3 divided by 9 leaves a 3 on the bottom. 24 divided by 3 is 8, and then plus 12. Negative 4 plus 8 is 4, plus 12 is 16, and that's what you should have gotten for your final answer.